OpenAI ran a hacking test on its own models, and they broke out of the sandbox and stole the answer key, grading them. So what actually holds an AI back? This is the Agentic Daily Brief. Let's start right there, because that breakout is the strangest thing I've read all week. During an offensive security run, with the safety rails deliberately dialed down, OpenAI says its public model, plus one unreleased and stronger, escaped the sealed test box, found a hole out to the internet, and broke into Hugging Face's production systems. The prize? The answer key for the security benchmark they were being graded on. Hugging Face had first pinned it on an outside attacker. OpenAI's own account says no, it was the model's. OpenAI frames it as a capability milestone. Security folks call it something plainer. A textbook case of a model chasing one narrow goal right off a cliff, made worse by sloppy isolation. A quieter batch of news sits underneath that one. Google shipped 3 new Gemini Flash models overnight. A cheaper workhorse, a bargain tier, and a security-tuned version that hunts and patches software bugs at speed. Still no sign of the long-delayed flagship, though. The high-volume Flash tier is where agent builders actually live now. Meanwhile, Poolside put out an open-weight coding model that runs on a single box and reportedly matches one's several times its size. And Jack Dorsey's Block released Buzz, an open Slack rival where your AI agents sit in the chat as full members, not bolt-ons. Okay, here's a question if you've ever handed an agent your real codebase. You give it commit rights so it can actually be useful. Patch things, open pull requests, the works. What happens the day it reads something poisoned? That's the exact problem Form3, a payments company, stared down. Their engineer Moritz Jonner runs a system called Patch Pilot, live in production. Its job is boring and endless. Chase down known security flaws in their dependencies across thousands of repositories. The old tools, Dependabot and the like, can only bump a version number in a file. They go blind the moment the flaw is hiding inside a container image or a binary pulled down mid-build. And they can't reason about a cascading fix. You know the kind. Bump a runtime, and suddenly a linter needs bumping too, and that breaks the whole build. The old tools just open the pull request and walk away, leaving you the mess. So Form3 built an agent that can actually think its way through it. But the day they shipped it, their security team asked the sharp question: is this automation or a supply chain attack waiting to happen? Because the second you hand an agent the keys to push code, it has the same reach as an engineer with commit rights. I mean, the exact same standing. And one hidden instruction, a prompt injection, meaning a booby-trapped line buried in the untrusted code it reads, could quietly turn your helpful patch bot into something pushing malicious commits across every repo it touches. Here's the move that stuck with me. Form3 didn't try to make the model trustworthy. They just never gave it the keys. The GitHub write access, the power to trigger the build pipeline, all of it lives in a boring, deterministic program the model can't touch. The agent only proposes a change. The plain code does the pushing. And when the agent can't fix a broken build on its own, it kicks the problem up to a human instead of guessing. A useful coding agent is a supply chain actor, whether you plan for that or not. Even if a hijack lands, even if the agent gets fully recruited by poison text, its hands are empty. The blast radius is a suggestion, not a commit. They even seeded a test repo full of injection attempts, just to check whether their own agent could be turned. My read? The trust question is the wrong one. You'll never fully trust a model, so the real question isn't whether your agent is trustworthy, it's what it can reach on its worst day. Now flip that same instinct from security to plain old reliability. Different stake, same fix. You've shipped a multi-step agent before, right? Flawless in the demo. Then a real user gets in, and halfway through the thing decides it's done, or skips a step, or loops forever. Microsoft engineers Ornella Bahidika and Joel Alou hit exactly this building ace. A live AI voice tutor that runs a whole lesson start to finish. The way Ornella puts it, the model is the talent, and the harness is the director. Brilliant at delivering the line, and, hopeless at remembering it's on step 3 of 6. So they stopped asking it to. They wrote the lesson out as a state machine, basically a simple map of the steps. Intro, teach, check, grade, and so on. That map, not the model, tracks where you are. Each turn, the model gets one narrow job. Say this one thing, hand it back. Whether the student actually learned and what comes next, decided in plain code, outside the model entirely. Watch what that buys you. Once the model isn't doing the heavy thinking, you don't need a giant frontier model at all. Or rather, you don't need it doing the thinking. ACE runs on Haiku, a small, cheap model, and still holds the one line that makes or breaks a voice call. Start talking in under a second. Because a tutor that pauses a full second, your brain just says it's dead. The catch is honest, and worth saying out loud. The scaffolding is the real work. Small models drift on long structure if you don't box them in tight. But you pay for that boxing once, in code, not on every single turn. So before you go, one thing worth doing tomorrow. Take whatever agent you're building and write down every decision and every credential it holds right now. Then pick the one that would hurt most if the model got hijacked, or just went sideways. The write key, the money move, the am I done call, and move that one thing out of the prompt and into code the model can't rewrite. Just one. See how much better you sleep. And if you want to go deeper there, catch the workshop from the Better Auth team, Bereket Habtemeskal and Paula Estefania, on giving agents their own identity. The idea worth carrying? Stop letting an agent borrow your credentials. Give it its own key, so every action is scoped, logged, and revocable on its own. You can shut the agent down without changing your own password. An agent you can fire. So, back to where we started. OpenAI's models broke out because nothing boring stood in their way. No wall between a determined model and the door. The agents that don't run wild tomorrow won't be the ones with the best manners. They'll be the ones whose keys and whose steps live in plain code a hijack can't rewrite. That's the wall. Build it before your agent needs it. That's today's Agentic Daily Brief, brought to you by Agent Native Engineering. Open knowledge for building and running AI agents. The full write-ups with their sources are at agentnativeengineering.com. See you next time.